One of the most frequently missed questions on the Lesson 2 quiz this semester was the last short answer question where you had to compute two z-scores and compare them to determine which score was better. We're going to walk through one example of this here. This is a common example where student A took the SAT math and scored 350, while student B took the ACT and scored 15. We want to compare these two students' scores to determine which one is actually more impressive. SAT scores have a mean of 500 and a standard deviation of 100, while ACT scores have a mean of 18 and a standard deviation of 6. Because they're on different scales, we can't directly compare these two scores. Instead, what we'll do is we'll compute z-scores, which are directly comparable. We'll start with the z-score for student A. Z-scores are equal to that individual score minus the mean divided by the standard deviation. Student A scored 350 on a test that has a mean of 500 and a standard deviation of 100. Negative 150 over 100 equals negative 1.50. One of the most common mistakes here was flip-flopping these two numbers. In doing that, you'd end up with a positive number, which means that you're above the mean. In this case, 350 is less than 500, so we should have a negative z-score below the mean. Next, we'll compute the z-score for student B. They took the ACT and scored 15 on a test that has a mean of 18 and a standard deviation of 6. This equals negative 3 over 6, which is negative 0.50. After you computed the z-scores, you were asked to compare them to determine which score was more impressive. The SAT and ACT, you were told, are both normally distributed. So I'm going to draw out a normal distribution and show you where these z-scores lie to explain why the score on test B is better. This is a z distribution, which has a mean of 0 and a standard deviation of 1. First, we'll plot student A's score. They were 1.5 standard deviations below the mean. Student B was only half a standard deviation below the mean. As we move to the right on the z distribution, the percentiles are getting higher. In other words, the scores are getting better. Student A scored better than these students, while student B scored better than a larger proportion of test takers. And this is why student B's score is more impressive.